Hello and welcome to the lesson on the architecture of AVR CPU core. The diagram shows the architecture of AVR CPU core. It consists of arithmetic and logic unit, that is ALU, a fast access register file, program counter, instruction register, instruction decoder, status register, and a stack pointer. The ALU executes all the arithmetic and logical instructions. There are 32 8-bit general-purpose working registers in AVR CPU core and holds operands and result during the program execution. A compiled C program is stored in a program memory. The program counter points to an address location in the program flash memory. It always points to the address of the instruction to be executed next. Once the content of the program counter is put in the address bus and read control is enabled, the flash memory puts the instruction code in the instruction register. The instruction is then decoded by instruction decoder and passed to the ALU for execution. The ALU executes the instruction and updates the general purpose registers and status register. The status register is updated to reflect the information about the result of the operation. Data memory, that is the SRAM on the microcontroller, holds the data during program execution. Logically, the SRAM is divided into heap and stack. The stack pointer holds the address location of the top of the stack. ATMega328 microcontroller contains fast access register file consisting of 32 8-bit general-purpose working registers. These registers hold the operand and the result during the program execution. These are optimized for fast access such that instruction can be executed in a single clock cycle. It supports 4 combinations of data width for input and output. These are 1 8-bit output operand and 1 8-bit input result, 2 8-bit output operands and 1 8-bit input result, 2 8-bit output operands and 1 16-bit input result, and 1 16-bit input operand and 1 16-bit input result. The register file is mapped to the first 32 location of the address space. For example, the register R0 is assigned the address 00, then R1, 01, and so on and so forth. The registers can be accessed from a C program using a pointer pointing to the address of the register. For instance, if a pointer is pointed to the address 01 and it is assigned a value as shown, the register R1 is assigned the value. Register R26 to R31 of the register file can be used as 3 16-bit indirect address register pointers apart from their general purpose uses. This enables efficient address calculations for indirect addressing. The register pair R26 and 27 is identified as register X, where R27 is the higher byte and R26 is the lower byte. Similarly, R28 and R29 in pair is defined as register Y, and R30 and R31 is defined as register Z. In the different addressing modes, these address registers support fixed displacement, automatic increment, and automatic decrement. The status register stores the additional information of the result for the most recently executed arithmetic or logical instruction. For example, an add instruction may result in a carry which updates the carry flag in the status register. Similarly, a subtraction instruction may generate a negative or 0 result which sets the negative flag or 0 flag appropriately. This information is used to perform conditional operation which may alter the sequence of program execution. These conditional instructions are used to implement if-else statement and loops available in C program. The status register is updated after each instruction execution. The instruction set reference defines the flags affected for each instruction. The status register is referred as SRES in program for better readability. The address offset of 0x5f is used with load store instruction, and 0x3f must be used when SRES is manipulated using in and out instructions. Now, let us look into the various flags in the status register. The bit number 7, named as Global Interrupt Enable, identified as iFlag, enables or disables the interrupts on the microcontroller. If the bit is cleared, all the interrupts are disabled irrespective of the individual interrupt enable setting. The AVR CPUs provide instructions to load and store a bit in a register. The T flag, that is the bit number 6 of the status register, is used as source or destination in the operation. The half carry flag is used to indicate the generation of carry or borrow from the least significant 4 bits during arithmetic operation. It is primarily used in decimal arithmetic. Sign flag indicates the result of an operation is signed and is always exclusive OR of overflow flag and negative flag. 2's complementary overflow flag is set when the most significant bit of the result of an addition of two numbers with the same sign is changed. That means the addition of two positive numbers has resulted into a negative number. And the flag is also set when the subtraction of two numbers with different sign result in the change of the most significant bit of the result. That means the subtraction of a positive number from a negative number has resulted in a positive number, or subtraction of a negative number from a positive number has resulted in a negative number. Can you think of such scenarios? Negative flag indicates the arithmetic, logical or bitwise operation has resulted in a negative number. Zero flag indicates the operation has resulted in zero. Carry flag indicates the addition operation has resulted in generation of a carry, or subtraction operation has resulted in a borrow. Arithmetic Logic Unit (ALU) is a complex digital circuitry which performs arithmetic and logical operation on the operands. Generally, it takes the operands, performs the operation defined by the instruction, and stores the result back in the specified register. Sometimes the operations are performed between registers and immediate value. It executes instruction in a single clock cycle. The operations performed by ALU is divided into three categories. Those are arithmetic, logical, and bitwise functions. The status register is updated after execution of each instruction. With this, I shall conclude this lesson. The rest of the CPU components will be discussed in the subsequent lessons. Thank you.